So this lesson is on double angles. So on the screen, we have our double angle identities, and you'll notice that the location of the two is different than anything we've done before. So for a double angle, what we're doing is we're taking the angle theta and doubling it. So if we actually put numbers in here, and let's just say theta was 100 degrees, then we'd actually be finding sine of 200 degrees. And we're not really going to put a number in for theta. We're going to leave it as a variable, either theta or x. And we're going to calculate these things with variables. So just again, notice the location of the 2 on the inside in that argument. We can't divide by 2 and we can't factor out this 2. So there's one formula for sine of 2 theta, one formula for tangent of 2 theta, and then we have 3 variations of the formula for cosine of 2 theta. Down here, if the 2 is out in front, 2 sine of x means sine of x plus sine of x, that we have 2 of them being added. Sine squared x means sine of x times sine of x. And now we have sine of 2x or sine of 2 theta, which means you double the angle. And when we have these, we have formulas for them. So here's an example. Find sine of 2 theta if, and they're giving us a cosine value for theta, and they're telling us where theta is located. So when I do these problems, the first thing I like to do is the thing that I'm solving for, I just like to copy down that formula. So on my formula sheet, I find the sine of 2 theta formula and just copy it down. The next thing I'm going to want to do is any given information I have that I can put into this formula, I'm going to go ahead and do that. So they gave me what cosine of theta is. It's -3/4. So over here in the formula where you see cosine of theta, I'm going to replace that with a -3/4. Now, we still need to know what sine of theta is. I don't know what it is, but I have some information about theta. I know that it's located in quadrant 2 between 90 degrees and 180 degrees. And I also know the cosine value of that theta. So what I'm going to do is draw a triangle with theta as the reference angle in quadrant 2. And when I do that, I'm also going to label the cosine value of that triangle, meaning the adjacent side is -3 and the hypotenuse is 4. And I'm doing that from SOHCAHTOA. So again, I'm drawing the triangle in quadrant 2. Notice I'm drawing it where like the reference bow tie angle is. And then I labeled the sides -3 and 4 from the given information. Now we can solve for sine of theta. Sine of theta is going to be opposite over hypotenuse. You can do the Pythagorean theorem to find out that missing side, that opposite side of the triangle, and you get √7. So sine of theta is the opposite side over hypotenuse, so √7/4. And now I'm going to take that and substitute it into the formula. Notice sine is positive because we're in quadrant 2. So that's why that number √7/4 is positive. At this point, I'm going to just do arithmetic. You always want to make sure that your final answer is simplified and in some cases rationalized. And so my final answer is sine of 2 theta equals -3√7/8. All right, find cosine of 2 theta and tangent of 2 theta. Again, they're giving us some information about theta. This time it's in a different quadrant and it has a different cosine value. So let's start with cosine of 2 theta. Now, cosine of 2 theta has 3 formulas. All 3 formulas will get you the correct answer. For the first formula, you need to know the cosine value and the sine value. For the second formula, you only need the cosine value. And for the third formula, you only need the sine value. Because of what we're given in this problem, we're given a cosine value. I'm going to go ahead and pick the second equation because then I don't have to solve for sine. If you did solve for sine, sine's not very pretty. It's -2√2/3. And putting that into one of these formulas, just, not the simplest thing. So let's just make our lives easy and pick the formula with the given information we have. So now I'm going to substitute in that given information. the 1/3. And I'm just going to calculate. So this time I was able to get my final answer without having to draw a triangle like I did in the first example. All the given information, I was able to just use it in a formula. Now we still need to find tangent of 2 theta. So looking at the formula, I'm just copying it down. And I need to know what tangent is in order to do this, and I don't have tangent. So this is where I'm going to use the given information. This time I'm drawing a triangle in quadrant 4. Notice that in quadrant 4, I'm given a positive cosine value, which makes sense because all students take calculus. So when I label that triangle in quadrant 4, the adjacent side is 1 and the hypotenuse is 3 because I was given cosine. So cosine is adjacent over hypotenuse. Pythagorean theorem to find the missing side. And notice that that missing side is negative 2 root 2. And so now I can figure out what tangent of theta is from doing opposite over adjacent. So my tangent value is negative 2 root 2. Again, that makes sense because I'm in quadrant 4, so tangent should be negative in quadrant 4. So now I'm going to take that negative 2 root 2 and put it into the formula. If you had wanted to leave it as the square root of 8, negative and then square root of 8, you could have, and then at some point you'll just have to simplify. And now I'm just doing arithmetic, simplifying, and getting a final answer. All right, we're going to do one more example. And this last example is not a double angle identity. It goes back to the sum and difference identities. But this can be done kind of with the same approach as what we just did in the previous 2 examples. So now we're going to mix it in. So I want to find sine of A minus B. They're telling us angle A is somewhere in quadrant 2 between 90 and 180. And then they're telling us stuff about angle B, and they're telling us that B is between 0 and 90 in quadrant 1. So the thing that I'm trying to find, sine of A minus B, I go to the formula sheet and I just copy it down. And then I say, well, am I given any information to just put right into this formula? Yes, I'm given sine of A is 4/5. So I'm going to put that in for sine of A. And I'm given cosine of B is 3/5. So I'll put that in for cosine of B. Right? So again, we now need what cosine of A is. I still need what sine of B is. These are 2 different angles in 2 different quadrants for this problem. So I'm going to draw a triangle for angle A in quadrant 2. And I labeled it with an A so that this way I don't mix up my triangles. And I was told sine of A is 4/5, opposite over hypotenuse. So I put the 4 as the opposite, 5 as the hypotenuse. I did Pythagorean theorem or Pythagorean triple to find the missing side is 3. And I labeled it as -3 because we're going left on the x-axis. So now using that, I can figure out what cosine of A is. And so cosine of A is -3/5. You can do the same thing and draw a new triangle for B. Angle B is located in quadrant 1. The cosine value was 3/5. And then I knew that this missing side of the triangle was a 4. And now I know that sine of B is 4/5. The thing to be careful about is your plus and minus signs as you go to different quadrants, right? So again, triangle A is in quadrant 2. So sine of A is positive, but cosine of A is negative. Triangle B is in quadrant 1, so everything's positive. So now arithmetic, watch your plus and minus signs, and get a final answer. All right, I hope you found this helpful. Have a great day.